I would now like to explain why folding a piece of paper into two parts for a total of 3 times would result in 8 sections. So here I have a simple piece of paper. Currently it has one section because there are no creases. I would like to now fold a piece of paper in half. This will be the first time of folding this piece of paper into 2 sections. And sure enough, when I unfold it, we have 2 sections. Now I want to fold again this piece of paper into 2 parts. I would like to note that I'm folding each of these 2 sections into 2 parts, as you can see from this view. Because I'm folding each of these sections into 2 parts, and I started out with 2 sections from the first fold, it would make sense that I would have 2 times 2 sections, which is equal to 4 sections. And now lastly for the third fold. So now I have 4 sections, as you can see from this view. I'm going to be folding each of these sections into 2 parts. So I'll be multiplying the number of sections that we have, which is 4, by 2. And now let's undo this. So I should have 4 times 2 sections, which is 8. But where did the 4 come from? From 2 times 2. So we really have 2 times 2 times 2 sections, which are 8 sections. This is an instance of using repeating multiplication. That means that a number is being multiplied over and over to itself. And the word for this term is exponents. So this is what happened for our example. First, we folded the piece of paper into 2 parts. Then we folded each of those sections into another 2 parts, forming a total of 4 parts. And then lastly, we folded each of those sections into 2 parts, creating a total of 4 times 2 parts, which are 8 parts. So what happened when we folded the piece of paper into 3 parts? First, we started out with one section. There are no creases. Then we did our first time of folding the piece of paper into 3 parts. And sure enough, when we unfold it, we have 3 parts. So we have 3 parts, as you can see. And now we're going to fold this into 3 parts. So we are multiplying the number of sections we already have by 3. So we are finding what 3 times 3 is. And sure enough, when we undo it, we have 3 times 3 sections, or 9 sections. What if you're curious and we wanted to know what would happen if we folded a piece of paper another time into 3 parts for a total of 3 times of folding the piece of paper into 3 parts? So now you can see we have 9 sections. There's a lot of sections here. And we're folding each of them into 3 parts. So we're multiplying 3 to the number of sections we already have, which are 9 sections. Making this a little bit more of a crease. And we unfold it. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we have 3 times 3 times 3 sections when we fold a piece of paper into 3 parts for a total of 3 times. So that's what seems to be the pattern when you repeat folding the piece of paper. It's repeating multiplication. That is that you're multiplying a number to itself over and over again. For folding the piece of paper into 3 parts for a total of 2 times, first we folded the piece of paper into 3 parts. This was for the first time, and this gave us 3 sections. Then we repeated this process over again, folding each of those sections into another 3 parts, and thus we are finding 3 times 3, which is equal to 9. So we had 9 sections. When we folded the piece of paper into 3 parts for a total of 3 times, first we folded the piece of paper into 3 parts. This left us with 3 sections. Then we folded each of those sections into another 3 parts, thus giving us 3 times 3 sections, or 9 sections. Then we folded each of those parts into another 3 sections. This gave us 3 times 3 times 3 sections, or 27 sections. And that is how many we had when we folded a piece of paper into 3 parts for a total of 3 times. So what is the pattern if I fold paper in this certain way? Well, we know if we fold paper into 2 parts for 3 times, we found the number of sections to be 2 times 2 times 2, or 8 sections. So that is repeating multiplication. We have 3 2's. If we fold paper into 3 parts for 2 times, that'll be 3 times 3, or 9 sections. So that is repeating multiplication. We have 2 3's. If we fold paper into 3 parts for 3 times, that'll be 3 times 3 times 3. We have 3 3's, and we're using repeating multiplication, and that will be 27 sections. So the pattern seems to be if we fold paper into A parts, where A is a normal counting number, a positive integer, B times, where B is yet another positive integer, the pattern seems to be that how many sections we would have would be A times A times A times A times A times A, B times. So, going back to our problem, what was if this could actually happen, if we could actually fold this piece of paper into that many times? If we fold paper into 5 parts for 7 times, we would have 5 times 5 times 5 times 5 times 5 times 5 times 5 sections, which ends up being 78,125. So good thing we didn't actually do that if it was possible, because that would be a lot of counting. Part 3 in this set of videos is about exponents. Attached is a link you can click if you would wish.